All right, I've already heard from two of you confusion about page numbers, which I didn't realize how many of you were using the ebook. So that's cool to hear that you guys were relying on the ebook that much. I hope you like it. But yes, so if you haven't figured it out yet, the textbook that you have now, your consumable textbook, has different page numbers than your ebook. It has the same content, but the layout is different, so you won't recognize it. So if we're in chapter 3 and you don't know the page number, you have to go to that section. So in the assignment sheet, I did put chapter 3-1. So if you're struggling to find the page number, rely on the section number and find the problems in that section. So there is a disconnect between the page numbers and the layout of the ebook and the consumable textbook. So best of luck figuring that out. I'm sure it'll be confusing from time to time. And we'll just have to work together and be patient about that.
Yeah.
So the textbook in front of you is page 189, and that's the same as the ebook, page 109. It's the same problems and the same content. Looks different. So on Monday we'll have a bell work quiz. I didn't do it today, but be ready for a bell work quiz on Monday. 1 and 2 are mixed up. You guys, number 2 is easier than number 1. If you want to switch them. If you want to begin with number 2, you can. It was supposed to go first. I mean, you don't have to erase or anything, but number 2 is easier. Kelly, I'm sure you're ready to go with number 2. How do you do number 2? It says, and even in the directions, it says solve by square rooting. You could honestly just use your number sense to tell me what x is. You know what x is if it equals 64. X is 8, right? Because 8 squared is 64. Is x anything else besides 8? X could be -8 as well, because a negative times a negative is a positive. So here I know the answers. And how do you guys feel about me just writing plus and minus 8? You recognize putting a plus and a minus there? And that's the same as x equals 8 and x equals -8. I just put the signs there all together. Let's see a hand raise if you've seen that plus and minus sign right there. Okay, thank you. All right, so to show the work there though, like Calvin just figured that out because he knows x squared. Yeah, well, there's 2 answers, right? Yes. So this is the work though that I want you to show. Like, yes, you guys are great with numbers, so you know this is an 8. But I'm going to show that by putting a square root bar. Oh, that's too light. A square root bar here and a square root bar here. And I say x is plus or minus 8. Can you see this orange color on the bar? Better do it even darker. So we square root both sides to come up with that 8 if it was, you know, a more difficult number. Number 1 is trickier. Joe, will you take your headphones off? Who's got earbuds in too? I've just been noticing. On that. Okay, so number 1 is trickier because this 10. So I want to make a note here. You have to isolate the squared term. So the 10 is like crowding the x squared. So I can't put a square root bar up over here. I would divide both sides by 10 first. So Kelton, when you said 3, like, did you do that division in your head? Or did you just think like proportionally? Yeah. So when I divide both sides by 10, I get x squared is 9. Canceled that 10 out there. Now I will square root the left and the right. And I get x equals plus and minus 3. So 1 and 2, I believe you've done before. Number 3, I'm not so sure about. Not so sure you've done one like that. So I'm going to switch screens so I have more room to show where everybody wrote the problem now. I just gotta look like I've definitely done that. Delaney, is that how the problem was written? Okay. So now I know I need to square root both sides. Square rooting will cancel out this exponent of 2. So I'll show my work with a great big square root bar here and a square root bar on the other side. So in this step, the power of 2 is canceled and we no longer need the parentheses. Whoops. The square root of 36 is 6, right, guys? But look, I'm going to write a plus and a minus 6 there. When I do the square root of 36 is 6, I put that plus sign and that minus sign there. All right, so I'm still trying to get x alone. So I'm going to add 5 here and add 5 here. The 5 is going to go right in front of these plus and minus signs, and I'm going to create 2 problems. I'm going to get that it's 5 plus 6 and it's 5 minus 6. So I'm separating the plus and minus sign. So x is 11 and x is negative 1. So 2 very different answers. And we could now plug these numbers in here, and the left side would equal the right side if you wanted to like go back and check. See a thumbs up if you've done a problem like number 3 before. Right. It looks kind of like vertex form. So something to think about. All right, I wanted to go back to yesterday's assignment. So let's look at that assignment. I also know that I didn't finish notes with you guys yesterday. So if you were working on number 3 and we ran out of time in second period and you want to look at it again. Were we working on number 3 at the end of class in second period? Or was it number 2? Oh, then we're good. We don't need to run over it. Alright, so here's number 2 from homework. What I will do is for the 2 people who told me they tried to use the ebook and the pages were wrong, you guys can show me Monday. But now you know. You gotta figure out those page numbers somehow. I can do it. You can do it. Do you have a good question? Number 3 was tricky. So the answers are for number 2, -1 and 3. So listen, the whole purpose of doing this is to find x-intercepts. All right, so as I walk around, I might see 3 perfectly correct graphs, but I need to see that you actually box the x-intercepts, the solutions. The answer isn't necessarily just the graph. It's identifying where the graph crosses the x-axis. So we're at -1, 3 here, and then number 3 was a little challenging. So I'll show you the work for that. Number 4, the answers show up pretty quickly in the table. Do you plug a positive
I had 2.
Everybody go at number 2, should I move on to the next one? So number 3, like I did a full table. I found the vertex and I put it in the table. And I found this full table and I didn't get the x-intercept, so I had to keep going in the table until I crossed the x-axis. So I went 0, 1, 2. And then I saw that I couldn't quite see the x-intercept, so I went on to 3, and then I found a 0. We're looking for when y equals 0 for your x-intercepts. yesterday or the day before, the graphing, like do this negative 0 to 2a. That's what we're doing first. Is this same step into the graph. You just have to make your graph all the way until it goes to the end. So your notes on September 6th on your graph. You find them? September 6th. It would clarify something. So, did you just write this down? After it's recorded?
With a 10 minute. I know the big if you have your so teachers don't have to take a 10 minute.
Questions, you guys? That's it. Okay. Number 4. Here's number 4. All right, number 4 was out of order. So if there isn't a y or a 0 here, you have to rewrite it in standard form. So I added 8 over and got a positive 4. And this was the equation that I graphed, did all the steps for. So if it's out of order, you have to rearrange it for graphing. Well, these are the steps here. So if you can figure out exactly where you're all right, so negative b over 2a. So like in this one, what's tricky about it different than how we graphed before is that there would be 0 in the middle. It's like missing a term. So this is like y equals negative x squared plus 0x plus 4. The short little equation. The b is 0. One mistake we might make is calling the 4 b, but the 4 is c because it doesn't have an x with it. So for the axis of symmetry, I'm identifying a is negative 1, b is 0, and c is 4. So then your axis of symmetry is 0. And when you plug 0 in, you get y equals 4, because this will all just be 0. So that's where the vertex comes from. You put that in the middle of the table, plug in negative 1, negative 2, and 1 and 2. And these are your answers, so you're plugging in order to find this y is a 0 and this y is a 0. Those are x-intercepts. And those are the solutions. Negative 2 and 2. Anybody want to talk about graphing anymore?
Is it 199?
Probably need another day on that one. Alright, so guys, I want you to go ahead and go to page 105. And I want you to really these examples. And I would love to hear from you, like, wow, I don't understand how 49 turned to 80. I don't understand how 80 turned to 20. I don't understand how 20 turned to 4 and 5. All right, I want you to look at this and ask questions. I had both of them on here and I didn't. This is page 183 in your book. I want you to look at it. So it's 183 in the consumable textbook, 105 in the ebook. Thank you for whoever found that. So I remember reading it from you. So this paragraph is on the left, and then it launches right into these examples. I want you to read the examples and then ask questions like, wait, I totally understand what the book did here. Or no, I have no idea how these numbers changed. Okay, I want to see like how much can you learn just from looking at these examples without me saying anything. What can you figure out? Right, looking at A, who's got a question about the numbers? So you guys understand that 49 turned to 80 by adding 31, then dividing by 4. But you did this in geometry? I know some of you did. Did you ever break 20 into 4 times 5? Because 4 is called a perfect square, right? Okay, awesome. That's a perfect square. So you break it up into numbers that can square root. You square root the part that can and you leave the part that can't. All right, let's look at example B. Does everybody know we're on page 189? So this says that it has no real solution. Why does this one have no real solution and letter A does? You cannot square root a negative. So when I go to this step, boop, boop, I'm going to stop. The square root of a real number is not negative. We'll put no real solution. So be careful. be on the lookout for negative square rooting. You can stop for now. I think in the very next section, we'll start to square root those and we're going to work with that negative. But here we're going to stop and say no real solution. And then letter C is, the most difficult one. So this step here says multiply by 5/2. That's called the reciprocal, right? So if I had to get rid of a fraction, I would multiply both sides by the reciprocal to get rid of it. And that's where they got 25/2. Square rooted a whole fraction. Here they minus the 3. And then from here, I don't think you guys have ever seen a problem like that. Right about here, I think, is brand new to you. So there's a rule here. And I think the book mentions it in the paragraph, but they don't mention it here. I would be, would not be surprised if you stopped here and thought it was totally right. There's a rule that you cannot leave square roots in denominators. So their next step is trying to clear this square root from the denominator so that we can follow that rule. So their effort to clear the square root, they multiplying the top and bottom by the square root. So a square root times itself, like I could really show this as the square root of 50 over the square root of 4. This is like 2 times 2 is 4. And this is now the square root of 50. So the square root of 4 is 2. And so mission accomplished. There isn't a square root in the denominator. And then how did they go from 50 to this? They just broke it up, square rooted the 25 and made it a 5, kept the 2 in there. So these are your answers. They're really long, kind of weird looking fractions. So these were 3 examples. The first one I feel like you could do walking into the classroom. The second one I think you can figure out with very little effort. The third one I think is going to stop you guys for a while. It's going to be pretty challenging for a little while. So we need to focus on that third example. All right, so let's head down to number 6. Are we good? Oh, wait a minute. Try number 6 right now if you're ready. We're going to try to fit in 6, 7, and 8 before you go. 6, 7, and 8. So no decimal answers. I don't want a single decimal. No decimals here. Okay, so I minus the 14. And now I'm going to multiply by the reciprocal. Yeah, don't forget the plus and minus. I actually only give you half credit if you don't write plus and minus because you only give one answer. It's graded kind of harshly. So I'm hoping number 6 is A-okay, ready to go. Number 7 I think is more difficult. Let's get it set up, right? Good. I'm gonna pause here this fraction. This is right. Where I think things get weird. Number 7, I got this fraction. All right, I'm gonna square root both sides. And I get x equals plus or minus the square root of 7 over 2. No, you can't. There's a rule. There's like an unspoken about rule here that if no one ever told you about, you wouldn't know. You can't leave a denominator under a square root bar. The reason you can't is because like the square root of 2 is called an irrational number. It's a decimal that goes on forever. It never repeats. It goes on to infinity. Like square root of 2, we can't even write it. We have to keep it in its perfect form. So mathematicians, they were like, well, how can I divide by something that goes on forever like that? They call it irrational. So we don't like to have to divide a real number or we don't like to have to divide any numerator by an irrational number. So we want a denominator that really makes sense. So we don't want a square root in the denominator. So to clear it, I'm going to multiply both sides by that denominator. Let's rewrite it actually as a separate. Let's just separate the top from the bottom. Since it's the bottom that's giving us the trouble. Separated the top from the bottom's giving us the trouble. So I'm going to do the square root of 2 on top and the square root of 2 on bottom. I just multiply whatever is here to the top and bottom. And that's just a 1, really. You can multiply anything by 1. So here I am at plus and minus. This is the square root of 14 over the square root of 4. So this is the square root of 14 all over 2. And mathematicians, they said, okay, this is better. I know how to divide something by 2. I can picture it. I can kind of understand that concept. But dividing by this decimal here, they said was irrational. And now they call this denominator rational. We're thinking clearly now. Who's got a question on that process? All right, start number 8. All right, I've done 8. I hope you are too. Hope you didn't waste your time. I divided by 2 to start, just because you have to get these parentheses alone. And then I went to square root, and my red light went up. Wait a minute. I can't square root a negative. I'm going to not waste my time on that problem. It's no real solution. You will waste your time a couple of times, and that's okay. Just do your best to go back and fix it so you remember to look for it. Okay, I have 2 options for you right now. I can start your homework with you, maybe do the most difficult ones with you. Or there's a video I'm showing the rest of the classes on like one of the sciences that the book made a video about. So let's do a quick hands up. You want to watch a short video? You want to get your homework done? All right, let's do your homework. Let's go to 15. So I'm hearing 15 looks difficult. I kind of want to take a picture of the book so that we have the same. All right, I'm going to start with 15. So if you haven't done it yet, go there. If you have and you were confused, go there. -2 from both sides. I'm going to divide both sides by 4. And that's just setting the problem up correctly. I will now square root both sides. So when I square rooted, I wrote this before. When I square rooted, I had to drop those parentheses. I don't need them anymore. Because the 2 is gone, the parentheses are also gone. So not writing those parentheses is a big help. So I'll add 1 over, and my answer is x equals 1 plus or minus the square root of 2. No decimals here. And now I'm going to go to 17. I heard that one was really difficult. All right, on 17, I see that I have a variable on the left and right side of this equal sign. So I'm going to collect them together. I'm going to subtract 1/2 r squared from both sides. All right, 3 halves minus 1/2 is 2 halves. You just subtract those. If you have a common denominator, you just subtract the numerators. And so that's just going to be -10 equals r squared. And I will square root both sides. And then I will stop. And I will get no real solution. What should I say next? 18. 18? What are you going to say? 16. Yeah, I think 16 is better. I think I should do 16 next. I probably do have time to do both. Alright, I would put this 9 in, and first I plus the 5 over. And then I divide the 2. And do not make a decimal here. I won't even grade it at all. Now I square root both sides. Am I going too fast? No, I'm a little bit stressed out about this square root right now. I know I can't leave it there, but before I address it, I'm going to finish my problem and minus the 2 to the other side of the equal sign. And I get x equals -2 plus or minus the square root of 13 over 2, which is a pretty good job, but it's not done. We can't leave this denominator under a radical. That's a rule we've been talking about. So, we take that 13 away. I'm fine with the 13, whatever. It's the 2 that I have a problem with. I'm so annoyed all 3 of these have been 2, but if that was like a different number under there, if that was the square root of 5 under there, I'd be doing 5 here and here. So my answer is -2 plus or minus 26 over 2. You guys, if you weren't able to do the graphing yesterday, like I lost you, please come in after school today. We'll go through it a little bit.